Layered architecture. The layers that involved when a message is sent from one device to another device. That is the device A from the device B. So as the messages that are traveled from A to B, it may pass through many intermediate nodes. These intermediate nodes usually involve only first three layers of the OSI model. In developing the model, the designer distilled the process of transmitting data to its most fundamental elements. The communication is governed by an agreed upon series of rules and conventions called protocols. The processes on each machine that communicate at a given layer are called peer-to-peer processes. A communication between machines is therefore a peer-to-peer process using the protocols appropriate to a given layer. So this is identified which networking functions has related users and collected those functions into discrete groups that became the layers. This is also only involved in the first three layers of the OSI model. This one is the peer-to-peer process, the interaction between layers in the OSI model. This is the device A, which has the 7 layers, and this also the device B. This is also has the 7 layers. So fourth layer is the peer-to-peer control protocol, fifth layer, sixth layer, seventh layer. So remaining 3 layers that are involved in all the devices of the OSI model: physical layer, data link layer, network layer. At the physical layer, communication is established as direct. The figure given before, device A that sends a stream of bits to device B through the intermediate nodes. At the higher layers, the communication must move down through the layers on device A over to device B. Then it is back up through the layers. Each layer in the sending device that adds its own information to the message it receives from the layer just above it and passes the whole package to the layer just below it. Interfaces between layers: the passing of the data and network information down through the layers of the sending devices and back up through the layers of the receiving device, which is made possible by an interface between each pair of adjacent layers in the OSI model. Layers in the OSI model. This one is the physical layer. The main function of the physical layer is entirely responsible for movements of individual bits from one hop to the next hop, that is one node to the another node. The physical layer that coordinates the functions that is required to carry a bit stream over a physical medium. It deals with the mechanical and electrical specifications of the interface and transmission medium. This also defines the procedures and functions that physical devices and interfaces have to perform for transmission to occur. So this one is the typical diagram of a physical layer. Physical layer, there is a stream of bits which carries over a transmission medium from the physical layer to the data link layer. The physical layer that is concerned with the following. First one is physical characteristics of interfaces and medium. The physical layer which defines the characteristics of the interface between the devices and the transmission medium. It is also defines the type of transmission that we are used for communication. Second one is the representation of bits. The physical layer data that consists of a stream of bits, that is nothing but the sequences of zeros and ones with no interpretation. The bits that is to be transmitted, the bits must be encoded into signal, that might be electrical signal or a optical signal. The physical layer that defines the type of encoding, that is how zeros and ones are changed to signals. Data rate. The transmission data rate, that is number of bits that is sent each second, it is also defined by the physical layer. In other words, the physical layer defines the duration of a bit, which is how long it lasts. The fourth one is synchronization of bits. The sender and receiver not only must use the same bit rate but also must be synchronized at the bit level. In other words, the sender and the receiver clocks must be synchronized. Line configuration. The physical layer is concerned with the connection of devices to the media. In a point-to-point configuration, two devices that are connected through a dedicated link. But in a multi-point configuration, a link is shared among several devices. Second one layer is the data link layer. The data link layer that transforms the physical layer, a raw transmission facility, to a reliable link. It makes the physical layer appear error-free to the upper layer, that is the network layer. So this is the figure that shows the relationship of the data link layer to the network and physical layers. So from network layer to physical layer, and this one is the from physical layer to network layer. The data link layer is entirely responsible for moving frames from one hop, that is node, to the next node. Other responsibilities of the data link layer. First one is framing. The data link layer divides the stream of bits received from the network layer into manageable data units called frames. Physical addressing. If frames are to be distributed to different systems on a network, the data link layer adds a header to the frame to define that the sender and the receiver of the frame. If the frame is intended for a system outside the sender's network, the receiver address is the address of the device that connects the network to the next node. Third one is flow control. The rate at which the data that are absorbed by the receiver is less than the data rate at which data are produced in the sender. The data link layer imposes a flow control mechanism to avoid overheating the receiver. Error control. The data link layer adds reliability to the physical layer by adding mechanisms to detect and retransmit damaged or lost frames. It also uses a mechanism to recognize duplicate frames. Access control. When two or more devices are connected to the same link, data link layer protocols are necessary to determine which device has a control over the link at any given time. Network layer. Network layer is responsible for the delivery of individual packets from the source host to the destination host. The network layer is responsible for the source to destination delivery of packet, possibly across multiple networks, that is links, whereas the data link layer oversees the delivery of the packet between two systems on the same network. The network layer ensures that each packet gets from its point of origin to its final destination. If two systems are connected to the same link, there is usually no need for a network layer. However, if the two systems are attached to different networks with connecting devices between the networks, there is often a need for the network layer to accomplish source to destination delivery. Other responsibilities of the network layer, which includes the following. First one is the logical addressing. The physical addressing implemented by the data link layer that handles the addressing problem facility. In locally, routing, when independent networks or links that are connected to create internetworks, that is networks of networks, or a large network. The connecting devices, that is nothing but routers or switches, that is route or switch the packets to their final destination. One of the functions of the network layer is to provide this mechanism. Transport layer. The transport layer is responsible for the delivery of a message from one process to another process. The transport layer is responsible for process-to-process delivery of the entire message. A process is an application program running on a host, whereas the network layer oversees source-to-destination delivery of individual packets. It does not recognize any relationship between those packets. Other responsibilities of the transport layer include the following. First one is service point addressing. A computer that often runs several programs at the same time. For this reason, source to destination delivery means delivery not only from one computer to the next, but also from a specific process, that is running program on one computer, to a specific program, that is specific process running program on another. Other responsibilities of the transport layer include the following. Segmentation and reassembly. A message is divided into transmittable segments with each segment containing a sequence number. Connection control. The transport layer that can be either connectionless or connection oriented. A connectionless transport layer treats each segment as an independent packet and delivers it to the transport layer at the destination machine. Flow control. Flow control at this layer is performed end to end rather than across a single link. Error control. Error control at this layer is performed process to process rather than across a single link. Session layer. The session layer is responsible for dialog control and synchronization. The session layer is the network dialog controller. It establishes, maintains and synchronizes the interaction among communication systems. Specific responsibilities of the session layer include the following. First, dialog control. The session layer allows two systems to enter into a dialogue. It allows the communication between two processes to take place in either half duplex or full duplex mode. Half duplex is nothing but one way at a time. Full duplex is nothing but two ways at a time. Second one is the synchronization. The session layer allows the process to add checkpoints or synchronization points to a stream of data. Presentation layer. The presentation layer is concerned with the syntax and semantics of the information that is exchanged between two systems. This is the figure that shows the relationship between the presentation layer and the application layer and the session layers. The presentation layer is responsible for translation, compression and encryption. The presentation layer is concerned with the syntax and semantics of the information exchanged between two systems. Specific responsibilities of the presentation layer include the following. Translation. The processes, that is the running programs in two systems, are usually exchanging information in the form of character strings, numbers and so on. Encryption. To carry sensitive information, a system must be able to ensure privacy. Encryption means that the sender transforms the original information to another form and sends the resulting message out over the network. Compression. Data compression that reduces the number of bits contained in the information. application layer. The application layer is responsible for providing services to the user. The application layer enables the user, whether human or software, to access the network. It provides user interfaces and support for services such as electronic mail, remote file access and transfer, shared database management, and other types of distributed information services. Application services available and XA00 for message handling services, X.500 directory services, and file transfer, access and management, FTAM. The user in this example employs XA00 to send email messages. Specific services provided by the application layer, which including the following: network virtual terminal. A network virtual terminal is a software version of a physical terminal, and it allows a user to log on to a remote host. File transfer, access and management. This application allows a user to access files in a remote host and to retrieve file from a remote computer for use in the local computer, and to manage or control files in a remote computer locally. Mail services. This application provides the basis for email forwarding and storage. Directory services. This application provides distributed database sources and access for global information about various objects and services.